Welcome back, friends. We're going to do graphing polynomials. Now we're putting everything together that we've learned along the way. All right, so here is our check sheet or our checklist. And the first thing you want to look is how many changes or turns does it have? How many turning points? So remember, that's degree minus 1 generally. What's your y-intercept? Set x equal to 0. What's your n behavior? Remember, look at your leading coefficient and your degree, and then find your x-intercepts, set y equal to 0. Now, part of that x-intercepts is talking about multiplicities. So if you have questions about these first four, make sure to go back and watch those videos. But we're going to talk about multiplicities. What multiplicity means is just how many times does that happen. So let's take a look here. Go ahead and write this down in your notebook. You're going to want this, and it'll make sense in a minute. But odd crosses, even bounces. So what does that mean? That means if I have this form of a polynomial here, and this is in standard form, and then I went ahead and factored it out. Now, again, you're not going to know how to factor these until later on in the unit, but for right now, I've gone ahead and factored this for you. As we learned in a previous lesson, that means that these are our x's, set it equal to 0, and we would have x minus 7 equals 0, so x is going to equal positive 7, x is going to equal negative 1, x is going to equal positive 1, and x is going to equal negative 3. So we have 4 x's, and these are where they're crossing. Now, how many times does that occur? So our zeros are these, right? And our multiplicity is, let's draw these all the way down. Our multiplicity for 7 means that it only occurs one time. This one only occurs once. Oops, I should put that here. Oops, sorry. 1, 1. This one, again, only occurs one time and only occurs 1. Now, remember, 1 is odd, so odd means that it crosses. So what does that look like? Well, let's first establish what our n behavior is on this guy. So n behavior, remember, look to your first leading coefficient, and if it's positive, it's up, up, and if this is odd, you flip the first one. So this is up, up, and we are not flipping. So our n behavior is up, up, like this. Our x-intercept, now our y-intercept is 21, but we're not going to graph that quite yet. But here we have our x-intercepts like this. Now, 1 is odd, so that means that it is crossing, right? That's what we were just talking about. So it's crossing right here. So this is going to cross, 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 and cross. So our graph is crossing through those x's. And so what do I mean by that? Well, let's look at our n behavior is up, up. So it's going to look like this, right? Those are up, up from our x's. Now each one crosses, so that means it's going to go something like this. And do you see how I've crossed through each of those? Now, do I know how far down it's going to go? Absolutely not. Use a graphing utility like desmos.com or your graphing calculator, or you can plug and check if you really want to, but graphing is usually a good way. But this is a good sketch of the graph. So now you have an idea of what it looks like, and you know what numbers you need to plug in to figure out where it's going to go. Remember, our y-intercept is 21, and we know that because we set x equal to 0 here, and we were left with just 21. So what does that really look like? Well, if we cut right over to here, you'll see there we go. That is our graph. It crossed at 21 up here. And then it crosses here at negative 3, and it's very, looks like a bunch of lines because it's very narrow, but negative 1, positive 1, and positive 7, and there was that negative 3. Okay, let's talk about a multiplicity that isn't 1. A multiplicity that is not 1. So if we have this guy, all right, so here is our factored form, and typically, if they're asking you about the multiplicity before you know how to factor it, it's already going to be in the factored form. But you may look at this and we still want to know our n behavior. And to do that, we need to know our leading coefficient. So you look and see if any of your x's are negative. They are not. So that means this x is going to be positive. There's a 2 in the front here, so it's going to be 2x. So n behavior, and that really doesn't matter. You just need to know if it's positive or negative. So our n behavior is going to be 2x. Now you have to count the number of x's. Now this guy does not have an exponent on it, so we're going to put a 1 there. It's part of our invisible math, right? Things that we know are there, but that it's not written down. So we have 1, 2, so that's 3, 4, 5, 6, 7, 8. So this is going to be 2x to the 8th. That is our leading coefficient. I don't care about anything else that comes after that. Now, it's positive, so it's going to be up, up, and it's even, so we're not flipping. So our n behavior is going to be up, up, just like that. Now let's find our zeros. And in order to do that, you set each of these equal to 0. You factor it, and then you use your zero product property to set each of these equal to 0. If I add 3 and divide by 2, I would have x equals 3 halves, or 1.5, 1.5, right? Like that. X equals -4, x equals +3, because I would add 3 to both sides, and x equals -2. Now, the multiplicity on this one is 1. The multiplicity on this one is 2, because it occurs 2 times since it's squared. This one occurs 3 times, and this occurs 2. Now, remember, if we have from our previous notes, if it's odd, it crosses. So this is going to cross, cross, and this is going to bounce and bounce. So what do I mean by bounce? Well, here's what we do. We're going to take this and we're going to mark all of these on our x-axis. So 1.5 is going to be right here. Then we've got -4 and 3 and -2. Okay, so our end behavior, remember, is up, up. So it's going to go like this, up, up. Now, -4, it's going to bounce, and 3, it crosses. So this one's going to go through. -4 is going to bounce, and it looks kind of like this, just like that, kind of weird bouncing. -2, it also bounces because there's 2 of them. So it's going to go like that. And then 1.5, it's going to cross through. So it's going to bounce and then cross through. And in this case, we don't know what our y-intercept is, but again, we're just sketching what it should kind of look like. Know your end behavior, know your x's, and know if it bounces or crosses, that is what you need to sketch the graph. So let's take a peek at what this actually looks like. Now, these guys are going to be super skinny because it's a pretty big graph here. But again, you can see when I say bounce, this is what I mean. You probably see it better on this -2. You can see that it goes down there and then pops right back up, as opposed to this 1.5 where it's crossing right through it, or this 3 where again it's crossing right through that. So you can see that it kind of looks like our graph, except it's much skinnier, of course, because if we were to plug in these numbers into our original function here, then we could figure out, okay, where does it go? And we would see that it was skinny. But hopefully that gives you an idea of how to graph these without a utility, how to get a sketch, and then you use your graphing utility or graphing calculator to do the actual graphing to figure out your minimums and your maximums, and to make sure that you know exactly what it looks like. So hopefully this helps. If you have any questions, let your teacher know. Otherwise, we'll see you next time.